Hello everyone, myself Vishal Singh from SOS Indira Gandhi National Open University School of Sciences. Today we will talk about introduction of the chemical kinetics, which cover the courses coordination chemistry, state of matter and chemical kinetics, which comes under the program BSCG, Bachelor of Science and Bachelor of Science M multidisciplinary. The course code of this part of this lecture is BCHCT 137. So let's begin with the introduction of chemical kinetics. This is the structure of our today's lecture. First, we will talk about expected learning outcomes, means what we learn from this lecture, what are their learnings. After that, we will talk about the introduction, means what are the chemical kinetics, what are its significance, how we can define the rate, what is the importance of rate in the chemical kinetics or the reaction kinetics. And next we will define the role of the chemical kinetics. In this part we will define the rate of the equation, how to calculate the rate of the reaction, measurement of the rate of the reaction, and which factor which affect the rate of the reaction. And after that we will define the rate law, what are the rate laws, differential rate laws, integrated rate law, how we can calculate these integrated and the differential rate laws. After that we will discuss little bit about zero order reaction, not much but just the idea about that, because we will cover this zero order reaction, first order reaction and second order reaction in the next part of this lecture. What are the expected learning outcomes? So after studying this unit, the student or the learner should able to define the chemical kinetics and outline its significance. What are the chemical reaction, what is the significance, how it is important, and they are also able to do the state different way of expressing the rate of the chemical reaction, differentiate between different type of the rate of the reaction, what are the slow reaction, what are the fast reaction, how we can overcome the slow reaction to the fast reaction, how the fast reaction will occur, and how we can define these type of the reactions. Students can also able to describe different method of the following the progress of the chemical reaction, at which time this reaction will complete, or at this time or the interstitious time we can say what are the product or the yield of the reaction, which is the use in the industries use. And next, list and explain various factors affecting the rate of the chemical kinetics. What are the environmental factor or what are the real factor which can directly affect the rate of the reaction, how we can increase the rate of the reaction. And after explain the terms differential and integrated rate law and outline their significance, how we can calculate the differential rate equation and the integrated rate equation, what is its significance, how it is important. And after that they can define order of the reaction and outline its significance, what are the order of the reaction, how they can calculate, is the order of the reaction, it's just the stoichiometry or the molecularity of the reaction, what is the difference between these. And after that they can derive and analyze integrated rate equation for the zeroth, first and the second order reaction. Just little bit idea about this first, second and third order reaction. So let's begin with the introduction. In the introduction session, what we can say, what are the chemical reaction, why we are studying this chemical reaction. So in the chemical reaction takes place in the nature that produce organic and inorganic compound. These organic and inorganic compounds are mostly useful in any ways. We can say the different types of nature reaction which introduces the chemical reaction. First, formation and depletion of the ozone layer. In the environment we can see that the ozone layer is forming time to time and it depleted time to time, but due to the environmental constraint like pollution and other things, global warming, the rate of the depletion of this ozone layer is increased towards the formation. So it's more and more depleted form, so rate of the depletion is more than the formation. Photosynthesis, we all know what is photosynthesis. Just plants take the carbon dioxide, water and sunlight and just create the oxygen and energy in form of the sugars. And formation of the methane, it's just a one energy component form, important form, formation of the methane from the biomasses. All you should know. These are the basic chemical reactions which occur in the nature. biochemical reaction in our body, many from the birth to the death. Whatever the biological reaction and whatever the energy we are getting, just all are because of the biochemical reaction in our body, like acid base reaction, catalyzation, hydrolysis, enzymatic catalysis, and there are many more which is coming from microsecond to the millisecond or second. Some are in the hours also, but very less. So this is the nature phenomena where the chemical reaction occurred. Now, but the industries produces several type of chemicals that are drug, coating, adhesive, acid base, detergent, cleaning agents, and polymer. They all are industry products. These process formation should be economically viable for a chemical reaction. Why economical viable? Because they want to maintain the supply chain reaction. They want to produce more and more with very less time. So they should maintain the rate of the reaction. Why they should maintain the rate of this reaction? If the rate increases, the production will increase and the supply will be go on. So in industry, the rate is very important factor, because they want to produce more and more product from the less number of the reactant, so they can supply them. So the product have the high rate, high yield, and the economical viable, because they want to input less amount of money or less amount of this chemical reagents to produce the more and more amount of the product. So this should be chemically viable. So here the rate of the reaction come into the limelight. So this rate we will discuss it later. First, what is the chemical reaction? So here we will see कि industry have their own chemical reaction, and body at the biochemical reactions are in the nature have their own set of parameter of the chemical reaction. So again the question is come, what is the chemical reaction? So chemical reaction is just the some reagent is there at the some reactant is there, they give the product. Means one molecule is there, and just after applying some condition, whatever the condition, either environmental condition, either industrial, or either whatever the pressure, temperature, pH, whatever this factor, and they will just give the product. Means it is the phenomena where making and breaking the bond occurs. Just in the chemical reaction, some molecule will be lost and some molecule will be formed due to the making and breaking of the bond. Like some small molecule combine or join itself and make the big molecule, and the big molecule just break into the pieces and give smaller molecules. If we want to study the chemical reaction, means one molecule or the one reactant give the product form, so mainly some questions come in our mind. These are the basically three questions come in the in our mind to consider a chemical reaction. Like here the chemical reaction is given: A mole of A and B mole of B gives C mole of C and D mole of D. Suppose this chemical reaction is stoichiometry balance equation. A mole of A and B mole of B, we are giving the input, that is it is the reactant, and C mole of C plus D mole of D, it is the product. Means after giving input A mole of A and B mole of B, we are getting C and the D as a product of C and D moles respectively. So suppose this is the balance equation, and in our case it is the chemical reaction. So first question it is come in our mind, this reaction is feasible? क्या ये reaction होगा या नहीं होगा? This will be give the product or not? So just we'll go back to the thermodynamics. In thermodynamics say that कि the reaction will be occur only when the Gibbs free energy should be negative. Means Gibbs free energy, what is the equation? Delta G is equal to delta S minus T delta S, where delta is the enthalpy and T is generally the temperature and delta S is the change in the entropy. So if delta G should be negative, means T delta S term over dominant, or in some cases T delta H should be, if positive, so delta H will over dominate, then delta G negative delta H enthalpy should be negative, then delta G obviously it will become negative and the reaction is feasible. So this equation, if this reaction is feasible, is answered by this thermodynamics. How thermodynamics give the answer of this question? If delta G is negative, this is feasible or the spontaneous process. Means thermodynamics even also say that if this reaction is feasible or spontaneous, that doesn't mean it will be occur. Suppose we know that we have hydrogen, water will make up hydrogen and the oxygen. If in a beaker or in a water bottle we put 1 mole or several mole of hydrogen or the several mole of oxygen put together for the millions of the year, we can get a molecule of water? No, we can't get, because here the condition is important. Means the reaction is spontaneous, it doesn't mean it will be easily carried out. Some spark is needed. If we want a single drop of water or we want the water, then in the beaker we should anyhow manage the condition. Means we will spark them of the hydrogen or oxygen molecule, then we will get easily the water. Means here the condition is important. It takes million of years, but you can't get the single drop of water without the sparking. So here they say that spontaneously it is not possible we get the oxygen water molecule. So delta G should be negative, but some reaction goes to the slow process. Some reaction are the slow process and some reaction are the fast process. If delta G is positive, then there is no chance the reaction will be happened. Only the reaction will be happen, a reaction will be feasible when delta G is equal to negative. And if delta G is negative, it also possible it slow process or the fast process. The second question comes in our mind, how far will this reaction proceed? यह reaction कितने समय तक चलेगा या होगा या कितने समय में पूर्ण होगा? So this question is again answerable by this thermodynamic process. Chemical equilibria. You must have listened the word chemical equilibria. In thermodynamics you have learned also or studied also. In thermodynamics there is a equation delta G is equal to minus RT ln K, where K is the equilibrium constant, R is the gas constant and the T is the temperature. Again this equation will take our if we put the chemical equilibration constant K, then we will get how far this will be this process will be proceed. Again this question is answerable by the thermodynamics. And the next question it will come in our mind कि how fast will the reaction take place? कितना तेजी से यह reaction पूरा होगा? Earlier we have talked about the industry where they just matter कि in a feasible time they are getting more product or not. So this question is not answerable by the thermodynamics. Thermodynamics are silent about this question, how fast this process will take place. So thermodynamics only tell about the initial product and the final product. It just not tell about the whatever the path they have selected. Here the kinetics come into the part. Means how the reaction takes place and what is the rate at which the reaction proceed. So here we can say that thermodynamics only give the idea of the initial product and the final product. It doesn't give the what path it will be selected, but kinetics will give the answer of this question. If we take path A, suppose we can take path A, if we select path B or the C or some the other path, then the rate will be differ. Surely rate will be differ, and depending upon the path the reaction time will change, and this kinetics give the how fast or the slow process. Depending upon that rate or depending upon which path the reaction will select. So here comes the idea of the chemical kinetics. So basically this is the branch of the physical chemistry that deal with rate of the chemical reaction. Just we have talked about how fast or how slow the process is. factors that affect the rate of the reaction. Which factor affect the rate of the reaction? Means if the reaction is fast, how can we slow the reaction? Or if the reaction is slow, how can we fast the reaction? Which factor is affecting of this process? And mechanism of the reaction. From the chemical kinetics, we can also calculate what is the mechanism of the reactions and theories of the reaction rate. So first two part, rate of the chemical reaction and factors that affect the rate of the reaction, we will cover here, but the mechanism of the reaction and theories of the reaction rate we will cover later. So concept of the rate. What is the concept of rate? In day-to-day life, we have been talk about what is the rate of inflation, what is the population rate of the population growth, what is the rate of inflation, what is the rate of the bank interest, what is the rate of the economic growth. So in day-to-day life we have talked many rate, and just simply if someone is going from place A to place B, so we can simply ask you in which rate you will go to reach from A to B in 2 hours or 4 hours. So just we can say that it is the change of some parameter in unit time. Means some parameter is changes with time, it just give the rate. And rate is basically the three types: average rate, instantaneous rate and initial rate. Here we will not cover what is the initial rate, but we will cover the average rate and the instantaneous rate, because initial rate is just at the place we have started at t is equal to time 0, what is the velocity or what is the rate, it's just the instantaneous rate. So like water flow, the water flow we can give by the gallons or liters per minute. In 1 minute, which much liter of water is flow, it's just the water flow, it gives the rate, liters per minute or gallons per minute. In vehicles or in motorbikes, we have the speedometers. They just give the kilometer per hour, means the unit of this rate is kilometer per hour. At any time we are driving, at any time we can see from the speedometer and we can say that we are moving with x kilometer per hour or y kilometer per hour. At this place my speed was this x kilometer per hour, and at place B my speed was this much kilometer per hour. Means this speed is keep varying, means whatever the speedometer give the parameter, it's just the speed and it is keep varying. So like how we can calculate the rate or the speed? Means distance travel, whatever the distance we have traveled from going from A to B, then divided by just time. Means it is the function of basically some parameter with time. Means time is important parameter to calculating the rate of the any reaction or the rate of the anything, rate of the any parameter. Suppose we are going from Delhi to Jaipur. Let's take example, going from Delhi to Jaipur. The distance from Delhi to Jaipur, suppose that 300 kilometer, and we are covering from Delhi to Jaipur is in 4 hours. So what is the average rate? So we know that the distance from Delhi to Jaipur is 300 kilometer and we covering this distance in 4 hours. So then 300 divided by 4 is just 75 kilometer per hours. This is our average rate. The average rate from going to Delhi to Jaipur is 75 kilometer per hours. But it is not exact. This is the average rate. Means someone monitor time at the place when he or she is started and monitor the time when it ended their journey. And we want to calculate the instantaneous rate. What is the instantaneous rate? Means we are going from place A to place B, and at any places, but suppose here in the slide you can see that we have put the 2 red marks. Suppose marks 1 is at the place of Rewari. I want to check our speed at Rewari. So how can we calculate? Just from the speedometer we can check our speed at the Rewari is x kilometer per hour. Suppose in the place B like Alwar, we want to calculate our speed at the Alwar. What is my speed? So just from the speedometer, because it keep varying, because it's not the average rate, it's instant at the particular places what is the rate. So we can easily check it out from the our speedometer. So like in this is the just the basic idea what is the average and the instantaneous rate. So again the different chemical reaction proceed at different rate. Like in your school level or in your practical classes, you must have do the, if you put the solution of silver nitrate and just put it into the solution of silver chloride, if these two solutions are mixed, you instantaneously found the precipitation of this product, silver nitrate, AgCl. So it's just it's the instantaneous reaction. Just you put the solution, you will get the precipitation. Means chemical reaction will has completed. It's very means within 5 to 10 seconds or even less than you get the precipitate. It is a very fast reaction. Again, rusting of iron. You buy a knife and put in the place, and you monitor day to day. You will not get anything. But after a year or 2 years, you get some rusting of this iron. It is the relatively slow process. Depending upon the environmental condition, you will get the rusting. But basically the iron or the iron pillar, whatever the iron is there, it rusts time to time. It's day to years process. It's relatively slow process. Carbon graphite converting to carbon diamonds. It is the millions year. Carbon graphite will convert to the diamond. But it takes the million. It is very slow process. So this is just the concept of rate. Some chemical reaction are very slow, some chemical reaction are very fast, and some in between these. How we can define the rate of the chemical reaction? What is the rate? Consider again a chemical reaction. Some reactant A forming the product B. Here the reactant molecule A is denoted by this red color and B is some simple this blue color. So A is converted to B. With time we can see that initially the molecules of A are more, or each and every molecule is from A. But as time increases, the formation of B increases, and at the end time, means at the reaction will going to complete, the molecules of B is more than A molecules is less, means at the time increases the reaction will proceed. So here again the average rate we can calculate from this equation, whatever we have given the chemical equation A to B, the change of the concentration. What is the concentration of A divided by time taken? So how can we define the reaction rate? The reaction rate is defined by what is the change is the concentration of B, means simply we can write delta means change of B in delta T times. Suppose T1 time we can monitor, we can looking the chemical reaction A to B, and at time T1 we can see that the concentration of B is X, and at time after some time at time T2 we can see the concentration of B is T2, concentration of B is B2 in time T2. So what is the reaction rate? Here B2 minus B1 divided by T2 minus T1. Simply the difference of the concentration divided by difference of at that time will give the reaction rate. Suppose we want to write it in terms of the concentration A, because A is again changing, A is changing, so we should write in terms of the A also. Here we will put the negative sign because rate can't be negative. That's why we put the negative sign for the change in the concentration A divided by the change in the time. So simply we can say that if we want to write the reaction rate, we can write it in the product form or the reactant form. If we write it in the product form, then it's simply delta B, concentration of B divided by delta of T and time difference. And if we want to write it in terms of the reactant, then simply we can put the negative sign because rate should not be negative. Delta of concentration A divided by delta of concentration T. Here the graph show that with time the concentration of A decreases, and at the same time concentration of B increases, and after some time it's give the constant value. That means the reaction will complete. So here in the graph we can we show that the variation of the concentration of reactant and the product as a function of time for the reactant for the reaction A to B. Consider again a reaction. 2 mole of A plus 3 mole of B gives 1 mole of C and 4 mole of D. Here this reaction again is stoichiometry balance. Here 2 mole of A and 3 mole of B, total 5 mole, and 1 mole of C and 4 mole of D, it gives 5 mole. Means 5 mole of reactant and 5 mole of the product. So in this reaction, how we can define the reaction rate? Simply, if we want to write in the product form in terms with respect to C, then simply at time t1 and at time t2 we monitor what is the concentration of product C and just take the difference of this concentration and divided by time, we will get the reaction rate. Suppose we want to here the product C is 1 mole, so there is no any problem. But if we write in terms of D is also the product, so we wouldn't put the negative sign because the rate should be positive. At time t1, at time t2 we monitor the concentration of product D, and simply we can put the delta D by delta T at time t1 t2 whatever we have monitor. Here we will put 1 by 4 because stoichiometric balance should be there, because 4 mole of D is there and 1 mole of C is there. If we put 1 by 4 and delta D by delta T, then it is our actual reaction rate. Again we want to write in terms of A, then we should write 1 by minus 1 by 2 delta of A delta by T, and if we are free to write in terms of the B also, then it is equal to minus 1 by 3 delta B by delta T. So simply in reactant case, if we want to write the rate, then the general formula should be negative.
Break announce kar do. We are going to take a short break.
Okay. After the break, we will continue this.
My name is Dr. Imran Khan, and I'm a PhD scholar. I have recently completed my PhD in psychology. एंड मैं ये कहना चाहूँगा कि सबसे पहले तो मैं इग्नू का शुक्रिया अदा करना चाहूँगा बिकॉज आई वाज वर्किंग इन अ गवर्नमेंट सेक्टर एंड इट वाज नॉट पॉसिबल फॉर मी to go for a regular, full-time PhD. So IGNOU gave me an opportunity to go for part-time regular PhD, and that helped me to achieve my dream. In terms of my journey, it was a very good journey and it was fruitful, and I learned so much out of it. And there were many challenges as well, for example, in terms of data gathering and sampling, because the topic which I had chosen was a bit sensitive. Well, my PhD topic was existential concerns, shattered assumptions and alienation in relation to exposure to violence amongst Kashmiri youth. I'm thankful to my guide as well, who helped me all the way, and all the faculty in IGNOU that helped me a lot. So that made my journey easy, and as I said earlier that it was not possible for me to go for full-time PhD because of my job constraints. So IGNOU gave me an opportunity, so a big thanks to IGNOU.
I am Bulbul Sohoria from Assam, Jorhat. I am currently working as an assistant professor in CKB Commerce College, and I have studied marketing management. MBA, Masters in Business Administration in Marketing Management, and I have secured gold medal from IGNOU in this last season. And I am very grateful towards IGNOU that they are providing me the opportunity to come here and take the gold medal myself. And it has been a very good journey, a wonderful journey for me, that I could be a member of this largest family in kinds of enrollment. And I take this opportunity to thank IGNOU for providing the flexibility and the access, 24/7 access to the study materials, which has given us the opportunity to take different subjects, different courses in different courses. And I am looking forward to take another subject in coming sessions.
This is Namrata Gopinathan. I am from Ahmedabad Regional Center. I've got gold medalists for Masters in English. One of the best things of IGNOU I've realized over the years, because my mother has also done her B.Ed from IGNOU, and that has encouraged me to apply for IGNOU while I'm working with an Indigo Airlines. And also one thing I noticed, as the airline is having an uneven shift, this is one of the greatest platform where you can check all the study materials at any given point of time, and you can study in your own corner. And we all think that how we can study when teachers are not available at given point of time, whenever you have doubts or anything. But let me tell you that IGNOU study materials are so organized. Along with that, it is very important for us to be organized when you're studying. That helps you to prepare timely and give your exam on time. I'm truly indebted to IGNOU as a university, and while I was studying, I was thinking that I'm not connected to the organization well and there. We are not meeting people, so somewhere that disconnect is there. But no, I would say that every point of time your regional center helps you in clearing your doubts whenever you have. All type of accessibility is there. We feel all the inhibitions would be completely dissolved. So I would encourage a lot of students to join IGNOU and get yourself that feather. Today I'm having that feather of Masters in English, and I wish all the gold medalists and also the PhD graduates right now a very happy future, and I hope you all listen to your inner calling. Thank you.
Before the break, we was talking about how we write the rate of this chemical reaction, whatever the stoichiometry balance chemical reaction. So in this part, for the chemical reaction where 2 mole of A and 2 mole of B gives the product of 1 mole of C and 4 mole of D. So for this we can write the reaction rate in product form as well as with respect to the reactant form, and each and every molecule of this part of this reaction. So the general form we can write, if we write the rate in terms of the reactant, then the rate should be negative 1 upon mu I into concentration difference divided by in which delta T time we have look at that reactant. And with respect to the product, we can remove the negative term and write it in term of the product form. And we can also write the unit of this rate. So simply here we can see that rate is nothing but the difference of the concentration divided by the difference of the time. So if the concentration different which had the unit of mole per liter, and that simply time we can write in the second inverse. So then the unit will be mole per liter into second inverse. Or if we can write liter as a decimeter, which is the standard unit, then we can write mole per decimeter second inverse, or mole decimeter to the power minus 3 and the second inverse. This is the overall idea of the how we can write the average rate of the any chemical reaction. What about the instantaneous rate? What is the instantaneous rate? Why it is important? So instantaneous, suppose the same chemical reaction 2A plus 3B gives C plus 4 mole of D. So instantaneous rate gives the concentration of the product or the reactant at any instantaneous time. Suppose we have the reaction, or we have the chemical reaction which is going on. We want to calculate the concentration of the any product at time t is equal to 5 second, or at time t is equal to 5 hour. So then this instantaneous rate will give the concentration of that product or the reactant at any time. So here the instantaneous rate is simply whatever we have seen in the average rate, simply the delta term, means difference term, replaced by the d. Means you have read the differentiation of any reaction. How we can after that we will see the how this d will become. Means simply d means very instant time, means concentration of C divided by the time, and simply 1 by 4 d of concentration difference divided by the time. And if with respect to the reactant form we will write, we will put the simply negative sign of that. Then the general formula should be 1 by mu I d of Ci, means concentration difference, and divided by the time. Suppose you look in this graph, the average and instantaneous rate at delta t tends to 0. You look this graph. If we are looking at the chemical reaction of their product at time t1, and we monitor what is the concentration of this product, and after the time t2 we again monitor, and simply we can get the difference of the concentration at time t2 and at time t1, and divided by t2 minus t1 we will get the average rate. What happen if we decrease the time? Means again we monitor the concentration of the product at time t3 and at time t4. Means the time gap should be small. So the concentration at time t3 is A prime and t4 is B prime. So then simply the average rate B prime minus A prime divided by t4 minus t3. If the difference of time will decrease time to time, and at a time when this difference is very small, means at time t, what is the concentration of that product? So simply it's if B prime A prime and B prime, the concentration on the product at time t should overlap, and this will actually not overlap. This is the very minute difference, and the time difference is simply t4 and t3 is tends to 0, means very small difference. Then this comes the idea of the instantaneous rate. Means at time whatever the time t, what is the moles are the what is the concentration of the product? It's simply the slope of the curve, whatever the concentration curve is there, then which is dc by dt, means it nothing but the slope at that point. Means if in this plot, the time plot, we want to find out the concentration of the product or the concentration of the reactant at a particular time, then we just find out the slope of the concentration time plot of that reaction. Means simply we can write the relation between instantaneous rate and the average rate is given by this equation, where dy by dt will give the limit delta t tends to 0 delta y by delta t. Here delta y can be replaced by the concentration of the reactant or the concentration of the product. So this plot is given by the hydrolysis of the zinc. Again, how the reaction rate are calculated. हम रिएक्शन रेट को कैसे कैलकुलेट कर सकते हैं? सपोज कि नाइट्रोजन डाइऑक्साइड will give the nitrous oxide and the oxygen. Here from the experiment we can see that they have experiment from the time t is equal to 0 second, 50 second, 100, 150, 200, 250 and 300 second. They calculated the concentration of each and every molecule of this given reaction. Means they calculated the concentration of nitrogen dioxide, nitrous oxide and oxygen and report their value. These are the concentration of N2, NO, O2 and oxygen, and they plotted the graph for the same concentration versus the time in second plot. And in the instantaneous rate, we have calculated that if we want to calculate the rate at the particular time, we have just calculate the slope at that time. So here the rate is simply defined by, if we write in terms of the NO means product form, nitrous oxide, then simply 1 by 2, negative sign is not needed here, because here it is we calculated the rate in terms of the product, and simply d of concentration of nitrous oxide divided by dt, and which gives 1 by 2 into slope of the tangent. At that point what is the slope of the tangent? From the plotting the graph, we look after the slope of the tangent is 1.30 into 10 to the power minus 5. So simply divided by 2 is just because of the stoichiometry. Okay, so 1 by 2 into whatever the slope of the tangent, it will give the rate of the reaction. Suppose we want to calculate the rate in terms of the oxygen, then simply here the stoichiometry constant is 1, so 1 into d of concentration of oxygen at the particular time into the slope of the tangent. Whatever the oxygen, here red plot is denoted by the oxygen, for the oxygen, concentration of oxygen. And if we want to calculate at 200 second at 200 second what is the rate of the reaction, then simply at 200 second we calculate the slope of that tangent, and we can simply get the rate of this reaction. Means simply the rate is calculated from the experimental data. Means how to measure the rate of the reaction? There are multiple ways to calculate the rate of the reaction. Some experiment you have done this measurement of the pressure of the volume. Suppose this is the hydrogen peroxide reaction which gives water and the oxygen. So simply measuring the volume of the oxygen gas evolved, we can calculate the rate of the reaction. This experiment you might have performed in your laboratory, titrimetry. Titrimetry is also a method from where you can calculate the rate of the reaction. You also perform the titration method or titration in your lab experiment. Suppose you are doing titration of the acid and base. Acid is in your beaker and base is in your burette, and you are dropwise added the acid in the base in the acid, and you have put some indicator like phenolphthalein in your acid, and at a particular time when a drop of NaOH or the base is added to the acid, it directly gives the pink color. Means at that time the reaction is completed and the acid and base is completely neutralized at that point. This is the fast reaction for the phenolphthalein, whatever the indicator you have used. So from this reaction you have, and regarding the data of this whatever the mole of NaOH is used, whatever you have taken the acid in the beaker, you just calculate the rate of the reaction from the acid base titration itself. Conductometry and potentiometry titration, in the same way you can perform the conductometry and the potentiometry. You can calculate the rate of the reaction. Many methods you have done in your lab courses to calculate the rate of the reaction. Spectrometry or the colorimetry, this you might have not done because this is in the later classes. From the spectrometry you also calculate the rate of the reaction. It basically we have at the basic principle Beer-Lambert law, and from there you can calculate what is the rate of the reaction. Polarimetry also, the inversion of the cane sugar, you might have done this because in sucrose, it's the dextrorotatory, and when we with water it gives the glucose, and fructose, which is dextrorotatory and levorotatory respectively. And from the polarimetry you can calculate the simply the rate. This just have the simple formula. You can put all the length and whatever the strength in terms of the concentration. You calculate the rate of the reaction. Now what are the factors which affect the rate of the reaction? हमारे क्या क्या factors हैं जो rate को affect करते हैं? Here we will little talk about the collision theory, because this collision theory is later in this lecture, means we will cover it in the later lecture, but here we will give the just idea of what is the collision theory. Collision theory say that the product is formed when two molecules are collide. How much fast they will collide? They will give the product. They will give the fast product. Means the gas molecule is there. So then two gas molecules collide easily and form the product. So the gases have the faster relatively rate of the reaction. After that the solution, after that the pure liquid and solid had the less give the slow reaction, because it is available for the surface only. Because molecule are strength, molecule are not movable, but in the gas molecule are moving from one places to the other person. Collision will more and they will form the more products. Concentration of the reaction, it also the important factor. If the concentration of the reactant you may increase, generally the rate of the reaction will increase, and if you decrease the reactant concentration, the rate will slow generally. But sometime vice versa may happen, means if you increase the concentration of the reactant, the product will form less, and decrease maybe more product will be formed. Temperature also important parameter. In the collision theory, if you heat the some gases, their movement will be faster. You know that it is directly proportional to the temperature. So you heat the some gases or heat the molecule, the product will be formed, means more molecule will be formed. It also depend upon the temperature. Here one Arrhenius theory is there. I am not discussing this Arrhenius theory here. It say that after 10 seconds the reaction rate is double. Means if you increase the 10 degree temperature, then the reaction rate will be double. But it is not true for the biological reaction. Catalysis, if you add the catalysis, the energy will be lower, path will be slower, and the faster product you will form. Industry mostly use the catalysis to increase the rate of the reaction and get the faster product. After that, what are the rate law? Actually the rate law is the combination of the rate constant and the concentration. Simply decomposition of the nitrogen pentoxide, it will give the 4 mole of nitrogen dioxide and the oxygen gas. So here this is the some experimental data कि initial concentration if we decreases, which is initially 0.3, then it is 0.15 and 0.1, the rate it simply decreases. For let's say for 3 molar, for 0.3 molar it will give 2.73 and into 10 to the power minus 4, and it subsequently decreases with the initial concentration. But if we calculate, if we give the difference of the rate and the concentration of nitrogen pentoxide, will give the constant value. Here we can say that there is a relation between initial concentration and the rate. Simply we can terms that it will give the K value, rate divided by concentration of nitrogen pentoxide, it will simply give the something constant value. So then we can write it as rate is equal to some constant value into concentration of N2O5. This equation we can tell us this is the rate law for this decomposition of the nitrogen pentoxide. Again take an example, this decomposition of hydrogen iodide. Here 2 mole of hydrogen iodide breaks into hydrogen gas and the iodine gas. Simply we can the rate and HI, first we will check it is the initial concentration of Si as decreases, rate decreases, and simply the rate divided by the concentration of Si, it will give the some value, but it is not constant. Again, rate divided by initial concentration of Si, and just we squared it, then we get it is the constant value. Means in earlier cases, first time rate divided by the concentration of nitrogen pentoxide, it will give the constant value, but here if the rate divided by second power of the hydrogen concentration of second power of the concentration of hydrogen iodide, we will get the constant value. Means simply the rate law can be written as rate is equal to something constant into Hi ka square. So then from these two data we can say that rate law not constant for all the cases. It should vary depending upon the reaction to the reaction. So but here we can say that a rate law is established experimentally and cannot be predicted from the chemical reaction. In earlier two examples, we give the experimental data. Just because of that, simply looking at the chemical reaction, we can't say that this reaction should first order, second order, one power or second power. On the basis of experimental data, we can establish the rate law. We see that reaction, 1 mole of hydrogen, a hydrogen gas, and 1 mole of Br2 gas gives 2 HBr, and from the experiment we can get the rate is directly proportional to 3 by 2 power of Br2 concentration and 1 power of hydrogen concentration divided by concentration of Br2 plus some constant of SBr. Means from looking this reaction, we can just see that rate is maybe just the some constant into hydrogen gas, concentration of hydrogen and concentration of Br2, but it is not the case. It is the very complex rate. So we can say that the rate law is established experimentally. We cannot justify or we cannot write by simply looking in the chemical reaction. Again, simply looking at the stoichiometry equation, it is not possible to decide that how the rate depend upon the concentration. You can look after these two example. Nitrous oxide gives nitrogen and oxygen. Rate is simply K into N2. Means if you look the stoichiometry equation, it should be K into N2O, a concentration of N2 to the power 2, but it is not the case. Again, 2Hi gives hydrogen gas and iodide gas. Simply you can write rate is equal to K Hi square. In both the cases it will be same, but for the nitrous oxide it should not be same. So means you can't decide the rate looking just after the stoichiometry constant. It is the purely experimental based on the experimental data of that reaction. After that we will discuss the differential rate law, concentration dependent rate, and the order of the reaction. Here looking from the previous example, we can say that for the nitrogen pentoxide will give the nitrogen dioxide or plus oxygen gas. So simply the rate law is given by rate is equal to K into N2O5P1, or rate is equal to, for the hydrogen iodide case, it is some constant into Hi to the power 2. So in this case simply the reaction rate should be some constant into concentration to the power some power, and this power is called the order of the reaction. This is generally decided from the experimental data. So simply we can write A plus B plus C give the some reactant, then the rate should be K, rate constant, concentration to the power A to the power P, B to the power Q, and C to the power R. Then overall order of the reaction should be P plus Q plus R. Here proportionality constant K is called as rate constant, R the rate coefficient. Sometimes it is called specific rate constant. So consider again a reaction. 2NO plus Cl2 gives 2NOCl. So rate should be K. From the experiment it is decided rate is equal to K into NO to the power 2 and Cl to the power n. Here the overall reaction is 3. Order of the reaction is 3, 2 plus 1. Order of the reaction 2 with respect to the NO and order of the reaction is 1 with respect to the Cl, then the overall order of the reaction is totally 3. Again, from this order of the reaction you can calculate the unit, means what are the unit of the reaction, because as the order of the reaction changes, unit is changes. So for the zero order reaction, simply K concentration of A to the power 0 and the unit is mole decimeter to the power cube minus second inverse. It's 0, and the first order reaction it's simply second inverse, second order, third order and fourth order. Simply for the, if we calculate the order of the reaction for nth order, then we can calculate it mole to the power 1 minus 1 decimeter cube to the power n minus 1 into second inverse. Reaction not generally first order, second order, third order, it may. Okay. So for the 3/2 order reaction, the unit of the rate reaction we can write it, means simply n is equal to 3/2, then we can write mole to the power 1 minus 3/2 decimeter per cube n minus 1, n is here 3/2, then the overall reaction should be mole to the power minus 1/2 decimeter cube 1/2 and the second inverse. So whatever we have talked, we are just summarizing it. Initially we first do the what are the chemical reaction, nature phenomena, industrial phenomena, what is its significance, what are the basic question for the chemical reaction has to be asked, what is the rate of the reaction, what is the order of the reaction, how we can calculate the order of the reaction, what how from the just from looking the stoichiometry we can't decide what is the rate of the reaction, and in some part we have seen the how the rate we can calculate it, what are the factors that affect the rate law. We also discussed the what are the rate law. So we are just winding up this lecture, and after the next lecture we will calculate what is the order of the reaction, zero order reaction, first order reaction, second order reaction or the nth order reaction, and again we can simply talk the what are the difference between order and the molecular order and molecularity of the reaction or stoichiometry of the reaction. So okay, thank you.